If you use a tangent line equation, which is sometimes called the linearization, to estimate a value of a function f, your answer is not going to be perfect unless the original function itself was linear. But we can, if we have enough information, tell if our estimate, our linearization value, is an overestimate or an underestimate. So just notice that on an interval, a function can only do one of these four different combinations of things. The function could be concave up and decreasing, like this one here. Concave up because it looks like a smile more than a frown, and decreasing because the slope is negative. It could be concave up and increasing, like this one. It could be concave down and decreasing, or concave down and increasing. So these are the only four possibilities, so take a look here. If you're going to use a point from a tangent line, so I'm going to use a point on that line to approximate a value of this curve, is my approximation going to overestimate or underestimate? Well, look at the whole tangent line. The whole tangent line in this scenario lies below the curve, except for that one point, the point of tangency. So if you use the tangent line to approximate a value of f, in this case, your answer will be an underestimate. I'm just going to write under, but you should write underestimate. Here also, here's my function f. My tangent line lies always under the function. So if I use my tangent line to approximate a value of f, I'm going to have an underestimate. And in these two pictures, the tangent line lies above the curve, meaning that if I use my linearization to approximate a value of f, I'm going to have an overestimate. So under, over, over. So look at the two situations where the tangent line was an underestimate. What do they have in common? Both of those scenarios included a function that was concave up. And for the tangent line to be an overestimate, all that's necessary is for the function to be concave down on the interval that we're interested in. So the interval that contains both the point of tangency and the x value that we're trying to find an approximation at. So watch the next page. So to summarize that, a tangent line, the linearization of a function f, is an overestimate anywhere that f of x is concave down. And the linearization, the tangent line approximation, is an underestimate anywhere a function is concave up because the tangent line lies below the curve. So let's see how this could actually get applied on the AP test. I wouldn't be surprised at all if you saw a problem like this. All right. So I have some information about a function. I know the function f evaluated at certain x values, and I know the values of f prime, certain x values, and I know also that, oops, put this on. Oops, I miscircled it. There we go. F prime of x, f double prime of x is greater than 0. That means f double prime of x is positive, and I want you to be thinking, whenever you see that, if you know f double prime of x is positive, what do you know about f? F must be concave up. So when you read f double prime of x is positive, f is concave up. So let's see what we have here. Write an equation of the line tangent to the graph of f at the point where x equals 1. That we knew how to do in chapter 3, maybe even at the end of chapter 2. We're going to use this line to approximate the value of f of 1.2. That's new for today. And then we're asked to decide, is that approximation an overestimate or an underestimate of the actual value of f of 1.2? Because our answer is not actually going to be f of 1.2, it's an estimate. And we have enough information to say whether it's going to be an overestimate or an underestimate. So here we go. I want the tangent line equation. That's it. I want the tangent line equation to f at x equals 1. Well, I know how to write a tangent line equation. I need an ordered pair. I know the x is going to be 1, and when x is 1, y is -4. And I need a slope. Well, the slope of f at x equals 1 is the same as f prime of 1, which I know is 5. It says m equals 5. So I'm going to write an equation that's y minus -4 is the same as y plus 4 is equal to 5 times the quantity x minus 1. This is a great answer. It gets 1 point for writing the tangent line equation. if you wanted to solve it for y or distribute, your choice, but not required. So I've been asked now to use this line to approximate the value of f of 1.2. So remember that f is approximately equal to the linearization function. And the linearization function is just this equation with y isolated. So I'm going to say that L of x is, if I tried to isolate y, I would subtract 4 from both sides. So 5 times the quantity x minus 1 minus 4. Now if you want to distribute, that's fine, but you actually save yourself some multiplication hassle, at least sometimes, if you leave this part of the equation factored. There's no problem if you want to multiply it out, you would still get full credit, but just watch how I'm going to save myself a little bit of hassle. And now my question is, what is f of 1.2? Well, I don't know, but I know f of 1.2 is approximately equal to, make sure those are approximately, L of 1.2, which is 5 times 1.2 minus 1 minus 4, which is equal to 5 times, oops, 0.2 minus 4. 5 times 0.2 is 1, minus 4 is negative 3. If I had distributed, it's not that the multiplication becomes difficult, but the multiplication is easier if you leave this here and take care of this subtraction first. So the answer to the second sentence of this problem, f of 1.2 is approximately equal to negative 3. So notice I have that statement here. F of 1.2 is approximately equal to negative 3. All right, so I figured out that f of 1.2 is approximately equal to negative 3. The next question is that answer an overestimate or an underestimate? Well, look up at the notes at the top of your page. We decided that if a function was concave up, the tangent line lies below, so the tangent line approximation is an underestimate. And remember, that's what we know from here. Whoops, from here. We know f double prime of x is positive, which means f of x must be concave up. The tangent line lies underneath. So here's my write-up. I would write that f of 1.2 is approximately equal to negative 3. And I'd say that this is an underestimate of the actual value of f of 1.2 because f is concave up on the interval from 1 to 1.2. I could have given a longer interval there, but just know that for this to work, for us to be able to know that our answer is an underestimate or an overestimate, the function has to have the same concavity on the interval that contains the x value that you wrote your tangent to and the x value at which you're trying to approximate the function.